Welcome back, everyone. This is session 2, and today we're talking about locators and basic interactions, which is really the heart of how you actually find things on a page and interact with them the Playwright way. Quick reminder of where we left off. In session 1, we got Playwright installed, we understood the browser, context, page architecture, and we wrote and debugged our very first test using the trace viewer. Today we go one level deeper. By the end of this session, you're going to know exactly how Playwright finds elements on a page, how to chain and filter those locators when there's more than one match, and how to actually interact with the page, clicking, filling forms, checking boxes, all of it. This is the session where things start to feel like real test automation, not just a demo. Just to ground us, session 1 covered the architecture, getting set up, writing our first test, and the debugging tools, headed mode, debug mode, UI mode, and the trace viewer. Today, 5 things. Why locators are Playwright's core building block. The built-in locators, getByRole, getByText, getByLabel, and a few others. How to chain and filter locators, plus a few handy methods like first, and or. The core actions, click, fill, check, select option, hover, and press. And finally, auto waiting versus explicit waits, when the automatic stuff isn't enough and you need to step in yourself. Let's start with a mental model shift, because this is genuinely different from how a lot of older tools work, and if you get this right, everything else today makes a lot more sense. A locator is not a reference to an element. It's a strategy for finding one, and that strategy gets re-evaluated every single time you use it. 3 things fall out of that idea. Auto waiting, every single action waits for the element to exist, to be visible, to be stable, and to actually be able to receive events before it does anything. Lazy evaluation, a locator only actually gets resolved to a real DOM element at the exact moment you use it in an action. Creating a locator doesn't search the page yet. It's just a description of how to search. And retryability, this is the big one. If the page re-renders in the middle of your test, Playwright just requeries the page using that same strategy. You don't get stale element reference errors, which if you've used Selenium before, you know is a constant headache. Let's look at the toolbox. Playwright ships 5 main built-in locators. getByRole finds elements by the ARIA row, button, link, heading, and so on. This is the one we're going to spend the most time on because it's the preferred choice, and I'll explain exactly why in a minute. getByText matches visible text content on the page. getByLabel finds the form field that's associated with a given label, really useful for form inputs. getByPlaceholder matches an input's placeholder attribute, and getByTestId matches a data tested attribute, which is a hook developers can add specifically for testing. Let's go deeper on getByRole, because I said it's the preferred locator, and I want to actually justify that, not just assert it. Here's what it looks like in code. Page.getByRole button with the name of signin.click, or page.getByRole heading with a level of 1, checking if it's visible. Why is this the one we reach for first? 3 reasons. It mirrors how assistive technology and real users actually perceive the page. Screen readers navigate by role. So if your locator works this way, your test is effectively verifying accessibility too, as a side benefit. It's resilient to CSS and class name changes, and resilient to general DOM structure changes. A developer can restyle a button completely, and your test doesn't care, as long as it's still a button with that accessible name. And it actually encourages your team to write more accessible markup in the first place, because now there's a testing incentive to do it properly. Common roles you'll use constantly: button, link, text box, checkbox, heading, list, list item, dialog tab, and menu item. Let's round out the other built-in locators with quick examples of each. getByText submit matches visible text, either an exact match or a substring, depending on how you call it. getByLabel email finds whatever input is tied to a label that says email. This is genuinely the best choice for form fields specifically. getByPlaceholder search ... matches the placeholder attribute directly. And getByTestId submit -btn matches a data-test ID attribute. This is your reliable escape hatch when a page just doesn't have great semantic markup, but a developer has added test IDs for you. Now let's talk about the escape hatch, raw CSS and XPath selectors. Here's an example, page.locator with a CSS selector like .card, :n, th dash, child2, space, button, .primary, .click. Playwright absolutely supports this through page.locator, but I want to be really clear. Reach for this last, not first. Here's why it matters. These selectors couple your test directly to implementation details. A simple class rename or a small DOM refactor and your test breaks, even though the actual behavior of the app hasn't changed at all. That's exactly the kind of flaky, high-maintenance test suite we're trying to avoid in this whole series. That said, there are legitimate cases, highly dynamic or completely unlabeled markup that you don't control, or when you genuinely need to target a specific structural position that semantic locators just can't express. Those are real cases. Just make sure it's actually one of those and not just the fastest thing to type in the moment. Let's put all of that together into one clear hierarchy, because I want you walking out of here with a decision-making framework, not just a list of options. Number 1, getByRole. Accessible, resilient. This is where you start every time by default. Number 2, getByLabel or getByPlaceholder. Great specifically for form fields. Number 3, getByText. Perfectly fine for static, unique text content on the page. Number 4, getByTestId, a reliable fallback when the application actually exposes test IDs for you to use. And number 5, dead-last CSS or XPath. Treat this as a genuine last resort because it's brittle and tightly coupled to implementation. If you remember nothing else from this slide, default to getByRole and only step down this list when you have a real reason to. Let's move into composing locators, starting with chaining. Locators can be chained together to scope a search inside another locator, narrowing down from a container all the way to one specific element inside it. Here's an example. We create a variable called product, which is page.getByRole-list-item.filter with has text iPhone. Then we say await product.getByRole button with a name of add to cart.click. What's actually happening here is that the second locator search only looks inside the descendants of the first one. That means we avoid accidentally matching an add to cart button somewhere completely different on the page that has nothing to do with the iPhone listing we actually care about. Filtering is how you narrow down a locator that's currently matching more than one element. Two main ways to use it. First, filter by visible text. Page.getByRole-row.filter has text product A. Second, filter by a nested locator, filtering rows down to only the ones that contain a delete button somewhere inside them. The options you have here. Has text keeps only matches that contain that specific text, and it accepts either a plain string or a regex. Has keeps only matches that contain a given locator somewhere inside them. And then has not and has not text do the exact inverse of those two. They exclude matches instead of keeping them. Sometimes a locator legitimately matches multiple elements, and you specifically want just one of them by its position. That's what these three methods are for. Dot first grabs the first matching element. Dot last grabs the last one. Dot nth with a number grabs the element at that specific index, and remember, it's zero based. So nth of 2 is actually the third item. One important caution here though, prefer a more specific locator over relying on position whenever you possibly can. Indexes shift the moment the list order changes for any reason. And now your test is quietly pointing at the wrong element without throwing any obvious error. Two more combinators worth knowing. Dot and this matches only elements that satisfy both locators at the same time. For example, page dot getByRole button dot and page dot getByText submit finds an element that is both a button and also has the text submit. Dot or this matches elements that satisfy either locator. For example, page dot getByText logout dot or page dot getByText signout handles the case where different parts of your app use slightly different wording for the same action. Alright, now that we can reliably find things, let's talk about actually doing things with them. 6 core actions to know. Dot click for buttons, links, and any clickable element. Dot fill with a string for text inputs and text areas. And this one actually clears the field first before typing the new value. Dot check and dot uncheck for checkboxes and radio buttons. Dot select option for select drop downs. Dot hover to trigger hover states or reveal a menu. And dot press with a key name like enter to simulate a specific keyboard key. Let's put this all together in one real example, filling out and submitting a login form. We navigate to /login, then page dot getByLabel, quote email quote, comma, dot fill comma with the email address. Page dot getByLabel, quote password quote comma, dot fill comma with the password. Page dot get by role checkbox comma with the name of quote remember me quote comma dot check. Page dot getByRole button with the name of sign in dot click. And then we assert await expect page dot get by text welcome back dot to be visible. Notice what we're not doing here. No manual waits anywhere in this test. Every single action just waits for what it needs automatically. That's the auto-waiting principle from the very start of this session, now actually in action. Let's actually pull back the curtain on what's happening behind the scenes when you call an action like dot click. Before performing that action, Playwright runs through a series of actionability checks on the element. Is it attached to the DOM? Is it visible on the page? Is it stable, meaning it's not currently in the middle of an animation? Does it actually receive events, meaning nothing else is currently covering it up? And is it enabled, not disabled? If any one of these checks keeps failing past the timeout, the action fails with a specific clear error message. And importantly, that error tells you exactly which check didn't pass. That's genuinely one of my favorite things about Playwright's error messages, because it turns debugging from guesswork into just reading what it tells you. Now, auto-waiting is fantastic, but it only covers actions on a single element. There are some situations where you genuinely need an explicit wait before you can even get to that point. Wait for load state, waits for the page to reach load, DOM content loaded, or network idle after navigation. Wait for selector, waits for an element to appear or disappear before you proceed with the rest of the test. And wait for response, waits for a specific network response to come back, for example, right after triggering an API call. These are the exceptions, not the rule, but they're genuinely necessary exceptions, and we'll actually use wait for response quite a bit when we get to session 6. Let's talk about anti-patterns, because I'd rather you see these now from me than discover them the hard way in your own suite 6 months from now. Hard-coded waits, await page dot wait for timeout 3000. This masks real timing issues instead of fixing them, and it slows your entire suite down for no good reason. Every single time you're tempted to write this, stop and ask what you're actually waiting for and use a proper wait for that instead. Brittle CSS chains, something like div greater than div colon, nth child 3 greater than span. This breaks the instant the markup changes even slightly, regardless of whether the actual behavior changed. Overbroad text matches, getByText submit, can accidentally match a completely unrelated element somewhere else on the page that just happens to share that word. And ignoring strictness errors, if a locator matches two or more elements, Playwright throws an error to warn you about that ambiguity. Don't just silence that error by slapping dot first on it as a reflex. Actually stop and figure out why there's more than one match, because that's often revealing a real problem. Your turn. 5 things to work through. 1. Automate a login form using getByLabel for the fields and getByRole for the submit button. 2. Automate a search flow. Fill in a search box, press enter, and assert that results actually appear. 3. Use dot filter with has text to click one specific item inside a list of search results. 4. Deliberately write a locator that you know will match two or more elements and actually go look at the strictness error Playwright gives you. 5. Fix that error using dot first, but only after you've genuinely confirmed that grabbing the first match is the correct semantic choice, not just the fastest fix. Let's recap. 5 things. Locators are lazy, retry-able strategies. They are not references to elements sitting in memory. Prefer getByRole-first always and only drop down to CSS or XPath as a genuine last resort. Chain and filter locators to scope your searches precisely, rather than hoping a single broad locator gets it right. The core actions, click, fill, check, select option, hover, press, all auto-wait for actionability on their own. You don't need to add anything extra, and reach for explicit waits only around navigation and network activity, not for individual element actions, since those already auto-wait by default. Next time, in session 3, we are moving into assertions, test structure, and hooks. We'll cover web-first assertions properly, soft assertions, organizing tests with test.describe and hooks, useful annotations, test.step for cleaner reports, tagging tests, and a proper strategy for test data. That's where our tests stop being isolated scripts and start becoming a genuinely organized, maintainable suite. See you there. Any questions, please post in comments section.